intelligent. Like, more than two. Only a few people about it.
Welcome, everybody. So today on Puzzle Time, you guys, first of all, just get to look and try to figure out what on earth is going on.
It looks like a number wheel.
Yeah, okay.
It looks like random lines.
Random lines.
It does look like that, but I'm assuming that there's some sort of pattern because it's math.
Is this like the math dimension, or you have to kind of figure out what's happening here?
I didn't know that that's what the math dimension is about. I call these mini mathematical universes, but you've seen these kind of things, and it's called the math dimension.
No, the mini mathematical universes.
Yeah. So this
yeah,
is
like the one where we had to find out where with the lines and numbers, with the numbers, no repeats, no. That one?
You're exactly right. Now the difference is the last mini mathematical universe that you guys saw.
On a square.
I only created it that day, so it was brand new, and it wasn't really perfect.
It wasn't the best universe.
This one was designed by a guy called Henry Picciotto. I guess I designed the mini mathematical universe, but he came up with the original idea. So, and this one's...
Is this on MathPickle?
Yeah, so you can find this on MathPickle, but I don't want you to look for it now. I want you to, now, you guys just have to solve it. You guys have to figure out what are the rules that I was trying to follow whenever I made this.
Will you give us the thing, you know, the little slideshow just to play with?
No.
Okay, that's fine. I just want to know.
Yeah, today's going to be different. But you're going to have fun today still. Yeah. So for those of you arriving late, this is a mini mathematical universe. And the objective of a mini mathematical universe is that you have to figure out what the heck is going on. You're in this universe, and there are laws. Unlike the real universe, where the laws are really complex to figure out, the laws of this universe are meant to be discovered. And they're meant to be discovered, I think today is for kids ages 9 to 99. So it's meant to be discovered for kids around that age, somewhere within those bounds.
I am almost 9, so does that count?
I don't think it's going to be like the craziest math equation, but I don't think it's going to be that simple.
Yeah, well, I want you to now maybe take 10 seconds of silence, everybody, and find a pattern. Avocado cream, you were exactly right. This is mathematics, so we want to be looking for patterns. You're exactly right. So now we're going to do it silently for 10 seconds. I want you guys to try to find some patterns in this diagram. Okay.
Already noticed something.
I found something.
Okay, so I'm gonna start with somebody new, and you know what? I think we should go back a little bit, and we should maybe introduce ourselves we're not a huge group, and we should just go around and introduce ourselves a little bit.
Yeah.
Yeah. So I'm going to start with the people who have been here for a while.
I've been here ever
yeah,
since it was
avocado-
new.
Yeah, avocado cream. You go ahead. You started off. Tell us something about yourself, where you are, and
Hello.
why you enjoy pickles. Why pickles are your favorite food?
My name is Ava, but my one of my internet names is Avocado Cream, specifically for MoMath, and I like cats, and I am in McAllen, which right now it's insanely hot because we're inside the equator, and I've actually never tried pickles.
Thank you. Stick person.
My name is Matthew. I go as stick person. I like programming, and I also haven't tried pickles before, or any pickled food for that matter.
Yeah.
Sully.
My name is Solomon. Solly, really whatever. I am currently in Manhattan, and I like pickles. There's this pickle place in downtown, and they have pickled French fries, which are really good.
Cool.
And I think Taco Cat wants to go.
Jess, you're new here, Jess. And if you want to say hello and something about yourself, where you are in the world, that would be great.
My name is Louise, but my mommy put me on Zoom, so her name is on it.
Okay, so it's Louise.
I like pickles, and I really like potato chips and pizza, and my name is Louise.
Okay, well, you are welcome. Bella, now I think I might be catching you in between mouthfuls here, Bella, but I think you're new here too, or have you been once before, or is this your first time? Oh,
my first time.
Okay. And where are you coming from, Bella?
I am from New York.
Mm-hmm.
My favorite food is French fries.
Cool.
Have you tried pickled French fries?
Okay. Liana.
Hi, my name's Liana, and sometimes my daughter Aiden is here with me. Except she's 5 and she has to go take a bath in a little bit. But I teach math to different ages and run like sort of exploratory math groups. And so I'm a little bit listening and a little happy to participate also. I don't know the answer to this puzzle, and I like spicy pickled okra.
Great.
Interesting food.
Never heard of it.
I've never tried pickled anything.
I never tried pickles with spicy before.
Oscar,
Bingo.
you're up, Oscar.
I'm actually just wondering what the puzzle is because I joined in late.
We don't
Right
know.
now, the puzzle is who is everybody on this Zoom channel? And then I'll explain this again, Oscar. Yeah, so now just to introduce yourself, where you're from, something.
Well, I'm Oscar, and I'm in California.
Hot over there?
It actually is a pretty hot day today.
I'm calling from Florida, and yeah, it's hot here too.
It's almost summer, so that makes sense.
Taco Cat, you're up.
I'm Taco Cat, although previous versions of my nickname were Pink Fluffy Unicorn, Hamlet Cat, and the White Rabbit. I am in New York, recently from Russia, and I like pickles.
Ruta.
Sprinkling math on pickles is good.
My name is Ruta, and pickles are okay.
And where are you calling in from, Ruta? It's just a brief intro for people.
Long Island.
Okay. Okay. Welcome. Tin Can. Hello.
Hi. Tin Can. And I'm right now in Brooklyn, New York. And I love pickles.
That's good for you. You probably love MathPickles.
It's almost time for the poll.
Somehow it's
we haven't even started
time.
yet. So we're going to wait a little while in the poll. Seth, go ahead. Seth.
Hello, my name is Seth. I play the violin. I don't mind pickles, but I wouldn't pick them out from a selection of snack foods.
Pick a pickle.
Oh wait, oh yeah, pick a pickle. I don't know. I like cats as well. I have a cat of my own. He's a chartreuse, but it's not spelled as you think it would be spelled. His breed name, chartreuse, whatever. Yeah. Okay.
Cool. Chai.
Hi, I'm from Vancouver, Canada, on the other side of some of you. If you're in New York, I'm on the other side of North America. I'm a teacher and I love pickles. And when I was a kid your age, people would call me Nickel Pickle because they rhyme. So I like math, I like pickles, and I have nickel.
Gabriella.
Nice. Math Pickle Nickel.
You're muted.
Yes, I'm muted. Sorry. I'm Gabriela Pinter. I'm originally from Hungary, but now I'm tuning in from Wisconsin, from Milwaukee. And I'm a faculty member at the University of Wisconsin-Milwaukee. And I love puzzles and I like pickles too.
Great. And I'm Gord, and I'm from Calgary, Canada. And pickles are, should I tell the truth? No, I can't tell the truth. Yeah, no, I eat pickles for breakfast, lunch, and supper. And
You don't.
yeah, that's basically,
yeah.
Whenever you eat pickles as your only food, you get a physique like mine.
Is that why it's called MathPickle?
So with that, we're going to start the puzzle. Oscar, for other people who were not here for the introduction, this is another one of these mini mathematical universes where you guys have to find out the rules. How did I construct this puzzle? What was I trying to do? And in this case, was I successful? Let's see.
I know.
Okay, go ahead, Sully. Tell me something you've observed. Just a small thing. Don't say if you've discovered everything.
There are no straight lines, just curves.
There's just curves. There's no straight lines. Exactly.
Yep.
Right. Yep.
This
Can I
is
go?
Curvy.
Yeah.
Can I go? I think I know how it works.
Okay, stick person, if you know everything, because we've been a long time getting to this point, if you know everything, just do one little drop of an idea. Okay, go ahead.
7, the sum of the blue lines is always the same. 1 plus 4, 1 plus 24 is 25, 2 plus 23 is 25, 7 plus 18 is 25.
Excellent, excellent. So all of those blue lines that you see there stick person has figured out, oh, they all sum to 25. Now we're going to have silence. I'm going to do the poll, and then we're going to come back. Here is the poll for everybody. Now, wasn't that a seamless transition to the poll?
I think I found this. I think I found one of the laws.
Okay, I'm going to go with. I'm going to wait until the poll is finished, and then we're going to see if anyone else wants to suggest any other discoveries that they found. And the poll. Okay.
Who has 5 people?
Yeah, some people have had 5 people watching.
One person. And one person had 4.
Yeah.
And then a lot of people have
9%. Okay.
Yeah.
Okay, so someone we haven't heard from before. We've got 2 clues so far. First of all, it seems like everything, all of the lines are curved. Solly's curved line observation. And then we also had that the blue lines always add to 25. And that was Stick Person who came up with that. Seth, can you give me another drop? Not the whole solution, just a drop.
Okay, so I noticed that all of these, well, each of the different colors connections add up to a certain number with like with 25 with the blue, but also 100 with the red.
Okay.
Yeah, that's what I realized.
And also,
okay. So thanks, Seth. So Seth has observed that all of the different colors add up to. So, for example, red. Seth observed 40 plus 60 is 100. 59 plus 41 is 100. 58 plus 42 is 100. It gets boring to keep on going, but I could keep on going. 57 plus 43 is 100. 44 plus 56 is 100. 55 plus 45 is 100. So you get the idea. Yeah. It's all of the colors get boring whenever you start adding them up. They're all the same.
Yeah.
Someone else. What else have you discovered? And Seth said that that's true for everybody. Seth said that that's true for all of the lines, all of the different colors. Oscar, is that a hand up or are you just stretching?
It is a hand up.
Go for it, Oscar.
I noticed that 21 and 22 are the only numbers that don't have a connection.
Yes. So what do you think is going on with this universe? What's unusual about 21 and 22, Oscar? Do you have any ideas?
Well, they don't have a connection.
Yeah.
And if they did, they'd have a line.
Yeah, they look so lonely, don't they?
Uh-huh.
I have really important information, new information. So basically,
Seth, I know that you've probably solved it. So
I didn't solve it, but
okay.
I think I have information.
Okay, but I'm gonna keep on going with new people, and then I'll come back to you, Seth, and Ruta or Taco Cat. Do you have any? I see that someone has written up here the numbers 9, 36, 25, 49, 64, 100.
I noticed the same thing as Seth at the same time he did. So
yeah, same.
Okay.
Yeah.
Okay.
Yeah, I noticed the purple after the green and then the red.
Okay, squares. Is that who's writing that?
All of these are squares.
Me. They're squares. They're all squares.
Oh, yeah. I saw these,
okay.
Those numbers right there, they match the colors on the circle, and all of them are squares too.
Yeah.
So the numbers they add up to are squares.
So 9 is equal to 3 times 3.
So 3 squared. 3
Yeah.
3 squared.
And
I
all
actually
the
know
purple ones
squared
are 9.
for my age.
Right? And the next one here is this blue one. Stick person already said that was 25, and absolutely that's a square number. And then 36, and then there's 49 and 64, this orange one. 64 is 8 times 8. And the reds are 100, that's 10 times 10. So exactly, this is a whole set of lines that create square numbers. Was I successful? What do you think I was trying to do here?
Cover up all of them?
I was trying to do all of them. And was I successful?
No.
No, Oscar just showed me that I was a failure here. So this is an example of me failing. I was trying to hook them all up. And after an hour, I'm left with 21 and 22 not hooked up.
And
So-
they don't.
Oh no.
And they don't sum to a square.
Yeah. Yeah. So that is where we are going to now switch to trying to understand this problem in a more general way. So I'm going to now shift to this, and
Paper.
we are on the paper now. You can erase all of the
Annotate.
annotations.
Because that just looked out of place now.
A little bit.
Someone accidentally left the dot right there.
Oops.
Blue dot.
Well, no.
That wasn't my dot. I erased what I wrote.
Okay, I can erase it if you want me to. Here we go. There we go. There, erased.
That was the quickest
Okay.
mathematical universe that we've ever solved.
Yeah, that was not that hard to solve, that one. Okay, Bella, I would like you to name a number, not a huge number, maybe a number between 5 and maybe 12, somewhere around there, Bella, between 5 and 12. And we're going to try to match up all of the numbers to make square numbers, okay, between 1 and that number. So name a number, Bella. What number would you like? Between 5 and 12, roughly.
5 and 12, maybe 7.
7. Okay, so we're going to do 7. Here we go. 1, 2, 3, 4, 5, 6, 7.
It's odd. No.
So I would like Liana and Aiden. Is Aiden there yet? That's okay. Well, you can link up any 2 of these numbers. Hi, Aiden. You can link up any 2 of these numbers, Aiden, so that they add to a square number. So let me write down the square numbers. The square numbers are those that form squares. So for example, oh, maybe I'll do it down here. Yeah, that's better. Okay, so we have just a single square, 1. We have this double square, which is, there's 4 of those. Then we have this one, which is
7
9.
has to link up with 2, right? Because
Yeah.
there's no other thing 7 could link up with besides 2.
But there.
Okay, so
7 is an odd number.
Aiden, you're
It's
going to go
be a
first,
number
Aiden.
left over. This is an
And-
impossible puzzle.
Okay.
I'm going to get Aiden to go first. So Aiden,
together
can you choose 2?
2 numbers?
2 numbers to go first. And you can also choose a color, Aiden. We've got lots of colors as usual. We've got lots of colors. There's just a sneak preview of the colors that we have. We've got lots of colors. We can color our rainbows. This puzzle is called Rainbow Squares, and it's by Henry.
Oh, you have to pick 2 numbers you can see here. Can you pick 2 numbers you see here to add to 4?
I think to add to 4, 1 and 3.
Got it. What color would you like, Aiden?
If you have red, I'll do red.
Okay, I have red, surprisingly. And
Nice.
there you go.
We're making our own mathematical universe.
main
Yes.
mathematical universe.
Okay. Tin Can, you're up. Name any two numbers that add to a square.
And 5.
Was that 4 and 5?
Yes.
And what color would you like?
Do you have magenta?
What would you say? Is anything like that? Is that
I
right?
guess the one in the middle.
Okay.
Yeah, that looks the most magenta. As an artist, I would say that that's magenta.
Okay. I'm gonna
Well, I
do-
am an artist, so yeah, I can easily guess that.
Nice fellow artists here.
Okay.
I strategy. We just take the smallest number with the biggest number. So we shouldn't use the smallest number up immediately. That's what I think.
7 and 2 are only options left.
Right. It's the only two left. I'm going to use the same magenta. Why am I using the same magenta for 7 and 2?
Same. It adds to the same thing.
And I doubt you can read.
It's like a weird rainbow.
And you know, you guys were laughing at me failing the last time I was trying to do numbers.
This is an odd number, so
you guys failed. Yes.
That's fair. That's fair.
We failed because there are an odd number of numbers, so we can't pair one of them no matter what we do.
I found a solution.
So there's many people speaking. What Seth just said was that, of course, this is impossible to solve because there's an odd number and we're trying to pair them up. Exactly right, Seth. Yeah. Sully, you were trying to say something at the same
If
time.
you add an 8, I found a solution.
Okay, I am going to add an 8, and then you want to, let me just go with this here. Okay.
Would have to pair with 1 if you went from 1 to 8, because it's the only thing that would work with 8.
Okay, so Ruta, can you? Okay, so we've had it solved. So you guys who are jumping out of your eggshells to solve these, I want you to go off and I will meet you again in 10 minutes. And I want to know which numbers can be solved and which numbers can't be solved. You've already shown me that odd numbers is useless. Okay, I totally agree. For those of you who are staying with me, you're going to be going at a slower pace. We're going to be just going, maybe we'll try 10 next. Okay, we'll try to solve 10.
I'm staying.
Okay, but for those of you who want, for those of you who are just like solving this before I even have time to ask anybody else.
Wait. Not all odd numbers are impossible. Or could you just say 1? Could you connect a number to itself? Could you connect 1 to itself and say 1 times 1 is 1?
No, these are lines. So there's not you have to have a line connecting one number to a different number. So for those of you who want to go off and solve this, so Solly and Seth and other people who just want to go and try to solve and coming up with bigger patterns. Okay, not just solving 8. You want to come up with bigger patterns. Go off and I'll get back to you in 10 minutes. Okay, so grab your own piece of paper and get ready to hold it up and to share with me in 10 minutes. Oscar, if you want to do that too, no problem. Taco Cat, Stick Person, if you want to do that too, no problem. Or stick around if you want. Yeah, stick around if you want. It's totally your choice. Okay, so that's exactly right. We've got one solution here. 1 plus 8 is equal to 9, and 9 is a square number. 2 plus 7 is 9. 3 plus 6 is 9. 4 plus 5 is 9. We're happy. Okay, we've for the first time we've got a solution here. So that's
yay.
Yeah. Okay, so that is grounds for celebration. now I am going to ask the most obvious question of all. What happens if you add a 9 and a 10? So I'm just going to scooch this up a little bit. There we go. And Jess, would you like to suggest 2 numbers here that add to a square number?
6 and 3.
6 and 3. And what color would you like?
Pink.
Pink. Pink coming up. 6 and 3.
We failed already. Because the 10 has to go with the 6.
Seth, you should be off doing this by yourself. You should not be now interacting with other people trying to solve this. Okay? I will talk to you in 8 minutes. Okay? Okay. I am now ready for, let's go with Ruta. Go ahead, Ruta.
So do we have to like add them up so they would be all the same?
You have to add them up so that they, yeah, okay, let's do that. Do as many pink ones as you want. I've got the pink pen out. That's a great idea, Ruta. Give me all of the pink ones that you want.
8 plus 1.
Okay.
Um, 4 plus 5.
Yeah.
7 plus 2.
Yeah.
Yeah, I'm pretty sure that's all.
Okay. Okay. Avocado cream, your turn.
Okay. So, can we like, I have a question. Can we like overlap numbers that we've already overlapped, or can we not? Is that illegal in this universe? I think that's illegal in this universe.
Your rainbows could be go through, but you can't visit the same number. You've used up 4. Okay, you've used up 6. So you can't use 6 plus 10 is equal to 16. Okay.
I only have one choice then.
Yeah, absolutely. 10 plus 9, a great square number, right? Avocado cream.
Wow, I feel so honored to put the last one.
And are you happy? It's a beautiful square number.
Maybe. I mean, I know what square numbers are.
Yeah.
I know. Don't ask me how I know. I know.
Right. So this is 1 by 1, 2 by 2. 3 by 3 is 9.
Yes. So 1 squared is literally just 1.
16.
Uh-huh.
And then the next one's 19, right?
Yeah. Oh, I'm sorry. I didn't do math in my head. It's like everything will be completely fine. Oh.
So the next one would be a 5 by 5. And you can actually
5 by 5.
Yeah.
Is the closest thing to 19, right?
It's the
5,
closest
10,
thing.
15, 20, 25.
It's 25. It's not 19.
It's so close though.
Yeah. So let's just go like this and go, ah. Okay. And just,
that's looks terrible.
so yeah, we totally missed it. So this is not a solution. I mean, I don't know if 10 is possible another way, but it's not possible this way.
Yeah.
Okay, so let's put that aside, and we know that we have to be very, very careful with 10 and 9. What are we going to do with 10 and 9 in order for this to work? So
You should probably make a 16 with them.
you think you can make a 16? Yeah.
I mean,
because
if you flip the 9 upside down, you get 6.
yeah, like if you can't get to 25 because there's not two numbers big enough to get to 25. And these are too big to get to 9. 9 plus 0. We don't have a 0.
Yeah.
So Oscar's right.
The
You've
only
gotta go
logical
for
thing
16.
is flip around the 6 or the 9 and then get 6 and then just do that.
Okay, so let me put this back again. Here we go.
And so you're going to make it and then.
Okay. I'm going to go with Bella. Are you there? Oh, there you go. Tell me two numbers that you'd like to connect. So the last time, Bella, this is what we ended up with. So one suggestion was that you needed to make 16 with these, and it looks like that's the only thing you can make with 10 and 9. So let's focus on the 10 and 9 first. I think that's a good direction. That's
Okay.
yeah. So what should I do here with the 10 in order to make the only square number that I can with 10? Any ideas?
10 plus 2.
10 plus 2. So let's look here. If you do 10 plus 2, which square number is it? 10 plus 2, that's going to be 12.
Well,
Yes.
Is that a square number?
No.
Oh,
It's
no.
nowhere there.
So go ahead, Bella. Tell me another number that you could add 10 to get a square number.
10 and 8.
10 and 8, what would that equal?
8.
10 plus 8, that would be 18.
And
that's also
where is
not a
that?
square number.
Nowhere.
Oh, no. Jess, what?
10 and 6.
Oh, Louise, do you have, what would you add to 10? Bella's suggesting, was it 6?
10 and 6.
10 and 6?
6 add
Right.
6.
Do you like that, Louise?
10 plus 6.
If you add 6
Okay,
to
okay.
10, you'll get 16, which is a square number, which is
Okay.
what we're looking for.
Okay. So what color would you like for that, Louise?
Do you have pink?
Okay.
Indigo.
We do have pink indeed.
So I'm going to go with Bella. Sure, I'll go with you, and then I'll get you choosing the next one, Louise. Okay. So you chose pink, and I just happen to have the pink out. So that was just handy.
I think I was
There you
purple
go.
or pink.
Okay. Louise, it's your turn. First of all, I'm going to ask you, what would you add to 9 to make a square number?
7.
9 plus 7, that would be
That was
16.
16 again.
Okay. Okay, looks good. So that's the only square that we can make with these two numbers. So we know that that's correct so far. Let's see. Ruta, any ideas? How to go from here? Let's instead of just choosing a number, are there any numbers that only have one thing that they can go to?
8, I think.
Sorry, I missed that, Ruta.
I think 8 can only go one way.
Only to 1?
Yeah.
Okay, because yeah, 8 can't go to it. 8 can't get to 16 because there's no numbers big enough. Well, 8 plus 8, but you can't go to yourself. So you can't go to 16, and it has to be bigger. It has to be bigger than 8. So the only one is 9. So you're exactly right. But actually, I promised, Louise, sorry, I promised to use your color, and I think you said this is your color. Is that right, Louise? Okay, I'm going for it. And I am connecting up these ones. There we go. Okay, so let's remove the annotations for now. And avocado cream, I'm going to get you not to solve it. I just want to know which two numbers, or is there a number that only has one solution?
I think 4 plus 5 equals 9. And we had 2 ways to get 16. And
9. But is that the only thing that you can do with 4? Is that the only thing that you can do with 5? Or can you do something else to get to a square number? So here are the square numbers. You're starting out at 5, and you've got the numbers 2, 3, 4 to choose from. Do you have any other options?
I don't think so.
No, I agree. What color would you like to choose? Nope, I'm taking that back. You don't have a choice. If you choose this one, you have to choose Louise's color. There we go. Okay. 2 and 3.
2 and 3.
Tin can. Tin can. Go ahead.
I found that so like 1 and 3, but I already see you have 1 taken, since 1 and 3 makes 4.
Right. So this, what do you think about this? 1 to 10.
Well, 2 and 3 is 5.
Yeah. So this particular setup didn't work, just like this particular setup didn't work. But have we gone through all of the different possibilities here? Have we shown that nothing works? Do we just have to work harder?
One more. I think
my I guess what we call theorem is that technically you could probably make it possible.
Okay, avocado cream. I'm looking for people now to give me a thumbs up or a thumbs down. Do we know that 1 to 10 now is impossible? I'm now going to invite back all of the people who you guys can now vote on this. And then I want to see some general stuff that you guys have come up with. Give me a thumbs up or thumbs down about what you think. Have we shown that 1 to 10 never works? Everyone's welcome to vote on this. Okay, we have a thumbs down. This doesn't work. We've shown that this doesn't work for everything. We don't need to do any more work.
May the 4th be with you.
Okay, I'm just going to mute you, avocado cream. You're a bit noisy there.
If you think it works, do you do a thumbs up or a thumbs down?
If you think you need to do more work, this is confusing. If you think you need to do more work, then give this a. You need to do more work. So you're saying more work. Give it a thumbs up. If you think no, this is absolutely impossible, and we've proven it's impossible, give it a thumbs down. Okay. We've got a thumbs down. We've got a thumbs up from Chai saying we need to do more work. We've got a thumbs up from Jess saying we need to do more work. We've got a thumbs down from Ruda saying we've done enough work. We've proven that it doesn't work for all combinations.
I was just going off by myself, and I found that 10 didn't work because, well, I can explain it in a little bit, but yeah.
Okay, so are you giving a thumbs up or a thumbs down for this?
I'm giving a thumbs down for this.
Right. Okay. Solly is a thumbs down. So you guys actually have done enough work. You have proven that this never works. Why? There's so many ways that you could combine it. You could do it like this. You could combine, instead of that, you could combine the 1 and 3, which we haven't done here or here. Why am I saying you've done enough
I think
work?
I know why. There are only 2 different perfect squares within range.
Okay, so the reason why you've done enough work and you don't need to do any more work is because the 10 only had one place to go. There was no other place for it. The 9, then you looked at the 9. The 9 only had one place to go. It has to go to 7. So you've covered these. These are for sure. In any possible solution, these have to be there. Then you looked at 8. 8, there's only one way to make a square with 8. It has to be this way. So in any possible solution, this has to be part of the solution as well. So now you've covered all of these and all of these. You've only got 4 numbers left. This is looking easier and easier. Then you look at 5. There's only one possible way. There's only one
5.
There's only one possible place for the 5 to go to make a square. This has to be there. You're left with 2 and 3 being lonely. You have solved this, and you have solved it without needing to do any more work with just a single diagram. So that's the beauty of being methodical and thinking about this problem in a different way, not just trying to go in and randomly choosing any 2 numbers that add to a square, but instead asking yourself, I wonder what numbers are forced, that there's only one possibility. In that case, we managed to solve it really quickly with just one diagram. Okay. Now, I would love to hear from some of those people who went off by themselves. For some of you younger people, you might just take this chance and say goodbye to PuzzleTime for this week, because this conversation now is going to be more for kids at a higher age group, okay, or a higher level of mathematics.
Wow, this felt incredibly short.
No. This is.
That's true.
No. This was a good length of time still, guys.
Like this only felt like
we did spend time introducing ourselves. But for those of you who want to stay, then we're going to get into other conversations, and you're welcome to stay. Good. Go ahead. Who would like to talk? Now, I'm not just interested in some patterns that you found for, let's say, 1 to 60. I don't want a solution. I want to know about a large number of solutions that you find. Patterns.
I found that 8 is the only number below 10 that can actually be solved below 10.
I put some more results, but I found a pattern that works for a lot of things and for an infinite amount of things.
Good.
But it doesn't work for everything. But basically, if the highest number in the sequence is an even number and one below a square number, then you will always have a solution, considering the fact that you can just pair 1 with that number, 2 with the number below that, and 3 with the number below that number below that number, and so on and so on. Like with 8, because 8 is 1 less than 9. Also,
right.
I proved
So
that.
what's the next time it happens, Seth?
Well, the next time it happens, because well, the next odd numbered square would be 25, meaning that the next time it happens is at 24.
Right.
And then, yeah.
So I mean, I might as well just give people a brief glimpse of it. I'm not going to write out the whole thing, but
in the end, it'll look like a
like
rainbow
this.
with one color. Yeah. Also,
and so you guys can see what's happening here. Seth is just saying, well, this is one less than a square number, and it's even. This number is even. The square would be odd. And look what happens. We have a solution that is just one giant single rainbow. Okay, so all of these just go back and forth, all of them, all the way down. So absolutely, this is exactly the type of big pattern that I really like you guys to find. Yeah, thank you.
Are there other solutions that don't fit this?
I found that 1 to 7 doesn't work and 10 to 13 doesn't work, but I found that 8 works and 14 works. Yeah.
Okay.
14 or 15?
18, 8 and 14 work. 8 and 14.
Okay. Any other people make discoveries that they want to share? I'm going to go back to the presentation now. And here we have a number 26. I will tell you right now that 26 has got 6 different solutions. These are difficult to find, but not impossible. Like, it's within your capability to find them, but they're not easy to find all of them. Okay. So this would be, if you would like to try this puzzle is easy. I'm giving you some hints. This puzzle is more difficult, and this puzzle is very difficult. And those are the 6 different solutions to the numbers 1 through 26.
Is there a link to the slide?
If you go to MathPickle, okay, you can find this under Rainbow Squares, this PDF.
Yeah, 14 works.
There we go. So yeah, maybe I should just leave you guys.
How come just 8 and 14 work?
8 and 14. Where do I show?
So well, I checked, and the only numbers that work from 1 to 14, or actually 1 to 15, are 8 and 14. For 1 to 15, only 8 and 14 work.
I'm trying 16 right now. If I can share screen, I'll show you.
Okay, I haven't tried that one yet, so good luck.
If I could screen share, I would show you that. So
you know what? I think that this is just fun for you guys to go and solve by yourselves. Those of you who are interested, you'll find all of these sheets on MathPickle. You will also find the solutions, but that's okay. And for this puzzle, you'll also see that although I failed to solve this in
the computer found 4 million solutions in 1 second.
Yeah. So yeah, I can't be very proud of that. Okay.
Maybe I'll write a program to do it.
Yeah. So I'm going to say goodbye from PuzzleTime with MoMath and MathPickle for today, and I will see you guys tomorrow.
Bye.
Bye-bye.
Bye, guys.